When we measure financial risk, the most common tool we learn first is value at risk, or VAR. VAR tells us the maximum loss we might face at a given confidence level. But there's a problem. It only gives us a cutoff point. It doesn't tell us what happens beyond that level or how bad losses can actually get. So in extreme market crashes, VAR hides the true severity of risk. To fix this limitation, we use expected shortfall. Expected shortfall improves upon VAR by taking the average of all losses beyond the cutoff. This means it considers tail risk and gives us a better sense of how large extreme losses might be. However, even expected shortfall treats all tail losses equally, and that may not reflect how investors really feel about risk. Some investors fear extreme losses much more than moderate ones. This is where spectral risk measures come into the picture. A spectral risk measure is simply a weighted average of losses, where larger losses receive larger weights. Instead of treating every tail loss the same, we assign importance based on how severe the loss is. In other words, worse outcomes matter more. These weights reflect the investor's level of risk aversion, making the measure more realistic and customizable. The key idea behind spectral risk is the weighting function. Each possible loss or quantile is assigned a weight. These weights must be positive. They must add up to 1, and most importantly, they must increase as losses become worse. This ensures that extreme losses get more emphasis. A highly risk-averse investor will choose very steep weights, heavily penalizing large losses, while a less risk-averse investor may choose smoother weights. Now, if we compare all three measures, the difference becomes very clear. VAR focuses on only one cutoff point. Expected shortfall averages the entire worst tail equally. Spectral risk measures go one step further by applying customized, unequal weights to the tail. In fact, expected shortfall is just a special case of spectral risk where all tail losses receive equal weight. So spectral risk can be seen as a generalization of expected shortfall. There are several advantages to using spectral risk measures. They account for the severity of extreme losses. They satisfy important mathematical properties like subadditivity, meaning diversification reduces risk, and they produce smoother and more stable estimates than VAR. Most importantly, they allow risk to match investor preferences rather than forcing a one-size-fits-all approach. In practice, spectral risk measures are mostly used by advanced portfolio managers, researchers, and financial institutions. They are more computationally intensive and require selecting an appropriate weighting function, which makes them slightly complex. That's why expected shortfall is still more commonly used. But conceptually, spectral risk provides one of the most flexible and theoretically sound ways to measure financial risk. So to quickly summarize, VAR gives the cutoff loss, expected shortfall gives the average tail loss, and spectral risk measures give a weighted tail loss based on risk aversion.